5.4, sum and difference formulas. Oh, you should learn how to use sum and difference formulas to evaluate trig functions, verify trig identities, and solve trig equations. Here's some more identities. These are called the sum and difference formulas. We have sine of u plus v, sine of u minus v, cosine, and tan. I personally always remember that for sine, you keep the sign, but the trig functions interchange. Like it's a mix of sine and cosine. Where on cosine, it's opposite. It's cosine, cosine always, but the sign switches from plus to minus. What are these good for? They're good for finding in-between angles, like cosine 75. Normally, if I draw cosine 75, here's 75. That is not a triangle I know how to do. I don't know the sides for that triangle. But what we could do is we could find two angles we do know that when you add them together or you subtract them, you get 75. My trick here, always use 45 degrees or pi over 4 if you're doing radians. That's always my trick. Make one of the things here 45 degrees. Here, what's the thing we could add a 45 to get 75? That'd be 30. I can make cosine 75 cosine of 30 plus 45. 30 plus 45 is 75. I know how to figure out trig functions with 30. I know how to do it 45. My trick is always use 45 for one of them. All we do here is follow the formula. So the formula for cosine is cosine 30 cosine 45 minus, it's opposite, plus minus sine 30 sine 45. That. And then we just got to evaluate this. Cosine 30, the little triangle here, boom, 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 30, 1 rad 3, 2. Cosine's adjacent for hypotenuse, rad 3 over 2. Since I'm here, I'm going to do sine of 30 also. Sine is opposite of hypotenuse, 1/2. Then we got to do cosine of 45, do a little 45 degree triangle. Maybe by now we have them memorized, we just do them in our head. This is 1 over rad 2. And there's another trick. The reason we use cosine of 45 is that we know sine of 45 and cosine of 45 is going to be 1 over rad 2, but the rationalized version we want to use rad 2 over 2. That's another trick why we always use 45, because it makes this part really easy. Like, yeah, cosine of 45, rad 2 over 2. They just rationalize 1 over rad 2. Multiply both top and bottom by radical 2, you get that. We're always using a rationalized version of cosine of 45 and sine of 45. That's another reason to use it, because sine of 45 and cosine of 45 are the exact same answer, rad 2 over 2. So you always want to use 45, makes life a lot easier. And then we just do the math. Rad 3 times rad 2 is rad 6 over 4 minus square root of 2 over 4. Combine that, square root of 6 minus square root of 2 over 4. That's what cosine 75 is. And that's how we use sum and difference formulas, by doing it that way. It's a little tougher for radians. This might be the one case where I'm like, it's easier because you're doing fractions. It's easier to figure out in degrees. Just convert it to degrees and solve it that way. But I'll do it in radians real quick. We want sine of pi over 12. Again, my recommendation, this is the one time you want to convert to degrees. This is much easier in degrees. But if you're doing radians, you want something where pi over 4 is bigger than pi over 12. You want something pi over 4 minus something equals pi over 12. You want pi over 4 minus something to get you that. If I solve this real quick, I get pi over 4 minus pi over 12 equals y. And then common denominator, I get 3 pi over 12 minus pi over 12 equals 2 pi over 12, which is pi over 6 equals y. This is saying sine of pi over 4 minus pi over 6. That's what pi over 12 is. This is why I say change it to degrees. Anyway, from here, you just use the formula. Sine formula is sine of the first one, cosine of the second one, u of v, sine of u, cosine v, minus cosine u, sine of v. Then you flip it, sine stays, and you flip it to be cosine of pi over 4, sine of pi over 6. Now, just like before, sine and cosine of pi over 4 is just rad 2 over 2. Done. Pi over 6 is 30. Didn't we just do 30? So it's the same thing. Cosine of pi over 6 is going to be cosine of 30, which is rad 3 over 2. And then sine of pi over 6 is sine of 30, which is going to be 1 over 2. And if you simplify all that, you're going to get square root of 6 minus square root of 2 over 4. You do get a lot of the same answers. I think this was actually the same angle. That's why it worked that way. But that's the idea, how to use that. So that's using to evaluate angles. My trick, always use 45 and always do it in degrees, because doing it in radians is kind of a pain. Next though, we can also use it to evaluate stuff. Like here, find the exact value of sine of u plus v, given that sine of u equals 45 and cosine of v equals negative 12 over 3. So we're just going to use the formula. That's going to be sine of u cosine of v plus sine of v cosine of u. Now what's going on here? They're telling us no, sine of u is 45, 4 over 5. That's done right there. And cosine of v, which is this one, is negative 12 over 13. I don't have sine of v. I know cosine of v. Well, I would make a triangle. They tell you where to make it. Quadrant 2. Cosine is negative 12 over 13. Luckily, this is a 5, 12, 13 triangle. This would be 5, and it would be positive. It's going up. This would be 5 over 13. Same thing with u here. I got to make a triangle for u. They tell us it's in quadrant 1, and sine is 4/5, 4 and 5. Also, luckily, that's a 3, 4, 5 triangle. Notice it's 3, and it's positive because you're going to the right. Cosine of u would be 3 over 5. That, we are adding them. And then we just multiply. When you multiply fractions, you do multiply directly across. Negative 48 over 65 plus 15 over 65. Now we can add the numerators. Now you get negative 33 over 65 is the answer. That's how that one works. You just follow the formula, and then you just got to figure out all the things they want. It made it a little complicated, but really you just make a triangle in the quadrant using the information given. Next one, write cosine arctan 1 plus arc cosine x as an algebraic expression. It's still a sum of difference formula. We're just going to use the cosine one. It's going to be cosine of the first one, arc tan 1, cosine of the second one, arc cosine x, minus, because remember it switches, sine of the first one, sine of arc tan 1, and sine of the second, sine of arc cosine x. That, just using the formula. This is like my UV. I was plugging this in the formula like that. This does look ugly. One good thing here is cosine and arc cosine cancel out. You just get x. That's about it. Arctan of 1. We're going to make a triangle out of that. Remember, it is tan, so it's 1 over 1, which makes this rad 2. Remember, once you make the triangle, you're done with this part of it. But what is cosine of this triangle? Cosine would be adjacent over hypotenuse. This is 1 over rad 2. Probably the rationalize, rad 2 over 2. Same thing here, sine of arctan. There's my arc. This is arctan 1. I made a triangle with arctan of 1. Opposite adjacent is 1, 1. Find out the missing side. Luckily enough, it was a 45, 45 degree triangle. What is sine of this triangle? 1 over rad 2. We're done with this one. We're done with that one. I need sine of arc cosine x. That one's a tougher one. So we got to remember arc cosine, we make a triangle out of that. Cosine, got x over 1. X goes here, 1 goes there. We got to find the missing side. A, B, C. I'm missing B. X squared plus b squared equals 1 squared. We get x squared plus b squared equals 1. B squared equals 1 minus x squared. And then you square root it. B equals square root of 1 minus x squared. That sine would be opposite over hypotenuse. So I get 1 minus x squared. And then these are both over radical 2. Sine them up. X plus square root of 1 minus x squared over square root of 2. Again, if you want, you could rationalize it, multiply both top and bottom by square root of 2, but I think this is fine. Kind of messy. It does get kind of messy. But really, you're just following the formula and just following the mathematics. If that's my UV, cosine of the first, cosine of the second, minus sine of the first, sine of the second. How does arctan work? You build a triangle with tan of 1. How does arc cosine work? You build a triangle with cosine x, and then follow from there. Let's prove this identity. This is our cofunction, and we want to prove it. So we're just going to do the same thing. We're going to use our sum difference formula. So we're going to do cosine pi over 2, cosine of the second one, x, plus, remember, for cosine it switches, sine of pi over 2, sine of x. Pi over 2, let's figure out that angle. So here's 0, here's pi over 2. That is a point. It's a point 0, 1. Remember, cosine is the x value. Sine will be the y value. Cosine there is 0. We have 0 times cosine x. Plus, sine is the y value of pi over 2, which is 1 times sine. 0 times anything is 0. We get 0 plus sine of x, which is just sine of x. And it's verified. I think we got one more. Find all solutions to this guy. We're pretty much going to do the same thing. We're just going to use our formulas. This is u and v, u and v. Sine formula is sine of x, cosine of the second, plus sine of the second, cosine of the first. So that's all this guy. That's where I got. That's why I paused for a second. I was like, wait, did I move on? Now it's just all this guy is this. And now this guy, sine formula is the minus 1, so it's sine of the first, cosine of the second, minus sine of the second, cosine of the first, equals negative 1. Almost forgot about that. Whew. Well, all these, those are our 45. They're all rad 2 over 2. Well, first thing I would do would factor out all the rad 2 over 2s. That's gone. I get rad 2 over 2, and what's left over? I have a sine x plus cosine x plus sine x minus cosine x equals negative 1. Well, this guy and this guy cancel out, and I get rad 2 over 2, 2 sine x equals negative 1. Let's try to solve this. Multiply by the reciprocal. 2 over square root of 2, get rid of this guy. So these cancel out. You get 2 sine of x equals negative 2 over square root of 2. Times it by the reciprocal. Try to get that sine by itself. Sine of x equals negative 1 over square root of 2. And this I could solve. Do they give me a domain? It is between 0 and 2 pi, so I'll have to do the general one. This we should know how to solve by now. All students take calculus. Sine's positive at a and s, so negative here and here, down there, and down there are my triangles. But really, anytime we see rad 2, we automatically know it's 45. Anytime you see that rad 2 is 45. And 45 is pi over 4, because we want to do radians. This is 0, pi, 4 over 4, 8 pi over 4. We're going a little past this one, so we're going to get 5 pi over 4. We're a little short of this one, we're going to get 7 pi over 4. And that's my answer. Messy, but it works. It's the lesson.